we sometimes we need to focus on shared database means to achieve the performance, including the criteria where some of the information in other service also we need to persist. Some of the information related to other service also we need to persist in our database. Okay. Just like I mentioned here, order service, customer service, inventory service, payment service, all those things. Okay. And our GUI is telling that customer order dashboard where customer eligible balance. So customer details are in available customer database. Order details are available in order database. But I'm not going to save complete customer information. Just like whatever I'm showing the minimal information on the order dashboard. Order dashboard, minimal information we are going to save so that you no need to look up every time. That is the shared database pattern is we need to save some of the critical information. Critical in the sense a primary key or else some information. For example, if you want to see payment processing, okay, for that order, for that payment, is it success or failure? That information, success or failure. Okay. So in our order main order table, we will save the payment status, customer eligibility. Okay. So these are the things which I'll go to, which I'll say so that I no need to look up on those things. So this is a typical idea which I gave you on a shared database pattern here. So I will recap because through your running notes, I am going to recap here because I didn't write any notes on the database pattern here, guys. Okay. Database pattern per service and shared database. I will write some notes and I'm going to recap here. Okay. Because sometimes notes is important here, guys. Okay. So I gave you complete overview on database patterns microservices. So I'll take any questions, guys. Once this is over, guys, I'll take any of the questions once it is over. Okay. So typically, I'll take a database pattern for services. I'll take a e-commerce framework also or any of the example here where everything is taken on one database. Okay. So for example, I'm going to take maybe you want me to write a diagram slowly, which is so database per service. Yeah. Now in this actually, what I'm going to have is let me write. So for example, what I can think of here, product service. Product service should have product database. Okay. Product service should have what? Product service should have product DB. This is pointing to here. Next, order service. Next, inventory service. Next, payment service. Okay. Next, shipment service. Like lot of things are available here. Like lot of things are available here. I'll take some of them. So we are going to have order DB, inventory DB, payment DB. So this is the typical overview of database per service. Am I right, guys? Every microservice is going to have now, sir, I think I explained this already, sir. Okay. So what are the benefits here? Database per service. What are the benefits I can say here? I'm just taking a notes here, guys, because I didn't write a notes. I only explained in last class. Benefits of this database per service. What is the first benefit I can say? Loosely coupled architecture. That's the first benefit, right? Loosely coupled architecture. If any service changes on technology, no impact on other service. That's what I mean to say that, right, guys? If any service changes on technology, it will have no impact on other service. Is it correct? Yes. That's the first benefit, guys. And also, second benefit is you can choose your own database, like relational, non-relational, in-memory databases as per business, as per business logic. So for one service, I can take a relational database. For one service, I can take non-relational database. For one service, I can take in-memory databases. Is that correct? Will you agree with me?
Yes.
For example, the same scenario, guys. Okay, same scenario, the same example. Product service, sir. Okay, I can take MongoDB also, product service. I can take, just like I'm telling, product DB in the MongoDB, because product is having lot of fields, right, guys? Lot of fields. So I'll take a JSON data and I'll update the JSON data. So product service. Will you agree with me, guys? Like product service, Mongo, NoSQL, order service, relational, and maybe I can say payment service, payment processing in memory. Sir, can someone go on mute, sir, if you don't mind? Thank you. Payment processing in memory. What do you mean by payment processing, sir? Just like I mentioned, right, in the microservices advantages, I created an order and payment is failed. I'm not going to roll back the entire order. I will retry. It's not a real payment, right? You understood? So those are the things I can take in memory database. These are the benefit here. Okay. And if you are using relational database also, guys. Okay. If you are using relational database, then I can have private tables per service. I can have private tables per service. There is a one area. I'll explain that. Schema per service. Database per service. So there's a small minute differences, guys, here. Private tables per service, database per service. So what is the meaning of private tables per space here? Each service owns its own set of tables. Each service owns its set of tables that must be accessed by that service. Let's say I can take one database and I'll take only the tables here. Private tables per service. Each service owns its own set of tables that must be accessed by that service only. Just like I told, right? I'm going to create users and roles and everything here. Okay. I'm going to create a users and roles and here, and that users and roles will be like, we are going to create like that. Okay. Where the role will be that particular user only and that particular table only, something like that. Next, schema per service, guys. Each service has its own schema. And authorization at schema level. Each service has its own schema and authorization is at schema level. Next, database per service is, generally each service has different connection string. Where it may be distributed also. Each service has a different connection string and the service may be distributed also. So these are the benefits I can think of on a database per service. Will you agree, guys? Any questions here on a database patterns, a database per service? I already explained. Just I'm giving a note so that it will be useful on that actually. Okay. Now I'm going to talk about challenges in the database per service. What are the challenges I am going to think of? So I'm going to write challenges. So challenges in database per service. Okay. What are the challenges we are going to get is, if it is private tables or schema, right? Queries that need to join multiple databases. If at all, if I want to look for the data where I need to write a query that needs to join or that need to get the data from multiple databases. Okay. That is a main point here where we have a solutions on other design patterns, CQRS, event sourcing, and API composition. So how to retrieve the data, how to efficiently retrieve the data across the multiple tables or multiple schemas. These are the design patterns we'll cover, guys, on this. These are the design patterns we'll cover on this. This is the first challenge, but we have a design patterns for them. CQRS, event sourcing, API composition are the design patterns which will cover them. That is the first challenge. Second challenge is transaction management. But this is not a challenge, right? As part of microservices principle, we cannot achieve transaction management, but we can use Saga design pattern to minimize the boilerplate code to achieve transaction management. First of all, transaction management itself is not there. What is the solution? We need to retry. Yes or no, guys? Transaction management, we need to retry. But if at all, in some cases, I want really transaction management should happen. Really, I want the transaction management should happen. Then in those cases, some design pattern, saga, choreography, and orchestration that will help us to minimize the failure and to and to minimize the boilerplate code. Boilerplate code to achieve the transaction management. Okay. So this is a typically on a database per service. I hope everyone is clear, right, guys? Whatever I explained, there is no difference here. Just like I given the benefits and challenges and what we are going to achieve this. Okay. And coming back to next one is shared database. Sir, any questions sir so far? As of now, any questions by so far? So database notes. Okay. Next one is I'm going to take shared database. I hope I have given that example. In the shared database, I have given the example, right, guys? This is sufficient, right? Do I need to write in a tabular diagram? No need, right, guys? You can understand, right? Yeah. Sir, I hope everyone is able to hear me clearly, right?
Yes, sir.
Can I think like that? Yeah.
Yes, we can. Yes.
Thank you, sir. Just like I'm not getting any voice. That's what I'm surprised. Okay. Right. Yeah. Now we are going to talk about shared database pattern. What are the benefits of the shared database pattern? Benefits of the shared database pattern is familiar services, data available in one service. Whatever the familiar service is there, the data should be available in that service. That should be retrieved from any other service or any other table. So I have the complete things are available in the shared database. Okay. Simple to operate and manage. Simple to operate and manage. That's the point here. But we may have a challenges. What are the challenges in a shared database point of view, guys? Runtime coupling. Right? At runtime, I can only get the data when the service is called other service, right? So there may be a challenge on runtime coupling. Also, development time. Development time takes more. Why development time takes more? For example, I have an order service. I need to talk to 5 services to get the complete data. Okay. For example, sir, I have an order service, sir. Okay. Where I want to get the product DB, order DB, inventory DB, payment DB. All the data I want to show because customer is clicking on complete order details. Assuming that while developing that, if inventory service is not sometimes it's coming, sometimes it's not coming. We have a problem with inventory and I move to SAP system and I have a challenge in connecting to SAP system. Then my development time will be impacted, right? So development time takes more time on the design point of view. Okay. We cannot guarantee or else I cannot say we cannot guarantee. Data will be available only when all services are, all child services, all dependent services are available. Data will be available only when all dependent services are available. Right? So that is the shared database concept here. That's the benefits as well as challenges. Do you see any other challenge or any other benefit apart from this?
No, so I could not understand the last one.
I'm not able to hear, sir. You are speaking on a speakerphone, or I don't know. Can you?
No, that last point I could not understand.
Okay, right. Last point, right, sir? Data will be available only all the dependent services are available, right?
Yeah.
For example, sir, I'll explain this. Okay, product service, one database. Audit service, one database. Inventory service is one database. Payment service is one database. Okay. What I'm doing is I am clicking a order. I have a GUI. It will show all the details. For that order, what are the complete products are there? Okay. For that order, what is the complete inventory? For that order, complete payment, complete shipment. I want all the details. Okay. What I need to do, if I have only main details are required, I may use one single schema where I'll take a few information. But I need all the details. Okay. Then what I'll do here, I will call the product service, inventory service, payment service, shipment service.
Yes.
Okay.
Correct.
Correct, right?
Yes.
If that service is available, then only I can showcase. Otherwise, I cannot showcase. It's only a limitation that data will be available only when all dependent services are, maybe I can say that, are up and running. Maybe I'll write like this. Where up and running, this will give more clarity here. Okay. Any other points you want to add, guys? Everyone is clear? Okay. Right. That's it, guys. So on the database point of view, these design patterns are sufficient here, but I'll go to this CQRS, event sourcing, API composition slowly because it's have a code and I'm going to discuss while writing after some of the patterns here. So database side, these are sufficient, guys. And I hope you got a clarity on a database per service, shared database. So you got some idea about that. Okay. Everyone is clear. Can we go to the next pattern, guys?
Yes, sir.
Let me repeat. Everyone is clear or any other questions from anyone? Okay. Now what I'm going to do is I'm going to cross-cutting concern. Now here onwards, code will be there, guys. Those who want a sir only theory, right? From now onwards, you are going to get a code here. Okay. Right. Next one is cross-cutting concern. Sir, what is a cross-cutting concern, sir? Cross-cutting concern design pattern.
Means
Cross,
the services, or you can say that the business requirements which are common to all.
yeah, I'll explain that. I'm going to explain. Okay.
We can
So what is it?
consider AOP.
Sorry.
Hi sir. We can consider like a core logic and cross logic. That means cross cutting in the sense transaction logging. This all will be under cross cutting
Correct.
answer.
Exactly. So,
Yeah.
So what I mean to say that, for example, I have 3 microservices, sir. Okay. I have 3 microservices. Okay. I'm going to have 3 microservices, assuming that. Okay. I have totally 3 microservices, guys. Maybe first microservices is customer management. Let me go to banking. Customer service. Another service is I have one microservice, customer microservice, deposit microservice. Another microservice is withdraw microservice. Deposit microservice, withdraw microservice, customer microservice. These are the 3 services I have. Okay. Sir, business logic of the customer microservice is different. Business logic on the deposit microservice is different. Business logic on the withdraw service also different. Do we have a same business logic for all these services? Are we going to have business logic same? No, right? Customer microservice deals with customer related operations. Deposit microservice deals with deposit related operations. Withdraw microservice deals with withdraw related operations, right? Yes or no, guys? But what is common here is, sir, logic is different, but some of the aspects where authentication, security, logging, security, logging, tracing, okay, security case, logging case, as well as tracing. Maybe I can say monitoring or health check. Yes or no, guys? Security, logging, tracing, as well as health check, discovery. I'll explain all those things. These are the code that should be available. Maybe I will remove. Yeah, discovery is also discovery. I can. Yeah, let me keep. I can keep this. Okay. So this is the code I should have. In every microservice, I should have this code. In every microservice, I should have this code. In every microservice, I should have this code. Apart from regular business logic. Regular business logic. Right, sir? Apart from regular business logic. Apart from regular business logic, these are the functionalities I should have. Will you agree with me, guys? Yes. Maybe what I can write here as part of running nodes is concerned. Okay. In any microservice overview, in any microservice, regular business logic will be there, and also apart from this, we may have some common aspects like security, logging, health check, transaction management, okay, etc., which are required, and these aspects may span across multiple services, right? We may have some common aspects like security, logging, health check, transaction, etc., which are required, and these aspects may span multiple things, okay? Now we have to implement. Sir, do we need to implement the same code in every microservice? Or can we have a common code? Can we have a common code? Okay. So rather than developing, guys, give me 1 second, guys. 1 second, please. 1 second. So by default, I'm sorry, guys. In any microservice, the regular business logic will be there. And also apart from this, we may have some common aspects like security, logging, health check, transaction management, etc., which are required as these aspects may span across multiple services. Give me 1 second, guys. 1 second, please. Yeah. So all these common aspects are required, may span across multiple services. So by default, what I'm trying to say here, we don't want to write a code in every service, and they are not our code. Okay. Definitely we need a framework level support. So by default, if a framework level support means in framework level tools available, where if framework level tools are available, then we can use by default, if framework level tools are available, then we can use across services like security. So when Spring Boot is concerned, we have almost tools, guys. We have almost all tools are available. We have almost all tools are all tools exist. We have almost all tools exist. And we no need to write any boilerplate code. But if you are taking other framework, that much of support might not be there. If you take .NET or if you take PHP, we need to, that much of support is not there. If you take security, I think you might have studied in Spring Boot, a complete wrapper is there. Enable web security, cars, all the security is maximum core framework is written. Logging, we can have SLF4j, Log4j, tracing, Zipkin and Sleuth, health check, right? Lot of tools are available. Health check itself, actuators are inbuilt Spring Booters. Okay, discovery, Eureka, gateway, all those things, guys. Maximum, apart from our business logic, whatever the things I am looking, all are available in that same microservice. So those things we are going to discuss in the cross-cutting concern design pattern. Okay. So everyone got idea about cross-cutting concerns, guys? All these are part of cross-cutting concern design patterns. So these are especially not real business logic. They are not my real business logic, guys. They are mainly useful for common aspects around my business logic. Okay. So the intention is, if a developer focuses on only on business logic, then you no need to worry about all those things, right, guys? If developer focuses only on business logic, we no need to worry about all those things. That entire infrastructure will be available. Clear? Sir, everyone is clear here? Yeah. Now, what I'm going to do is, we are going to have, there are two types of mechanisms, guys, where so there are two types of mechanisms where we are going to have our configurations, push based and pull based. For this, we need all the configuration, right, guys? These common aspects, we need a configuration, right, guys? For this configuration, we are going to have either push based or a pull based mechanism. Maybe I will take up them, guys, in tomorrow class, guys. Little bit early, I need to stop only for today, guys. Cross cutting concern. I'm going to upload the notes immediately. Database pattern. Database per service nodes. Shared database nodes. Sir, you feel this is a useful for you? Is it good for you, the material wise? Whatever the current mechanism Ashok IT is having, the nodes wise and everything? Guys, what happened, guys? No one is speaking today.
Yeah, it's good because of
Okay.
for future reference for
Yeah.
attending the interviews.
I mean,
Sometimes
I'm not talking about not notes. I'm talking about the tool. In previous, I used to have a Google Classroom. We have a Google Classroom where we can, in one place we can have this. But this is also one, okay, because I'm not able to do any PPT here. So we are experimenting on the PPT, how to share the PPT. We are experimenting. So some kind of challenges are there. Okay, fine. That's fine, guys. I'll see you tomorrow, guys. Have a great day. And only for today, I'm just exiting. And tomorrow I'll take this extra 8 minutes or 10 minutes. Okay. Thank you. Thank you, guys.